to the experts at the University of Alaska at Fairbanks, and one of the fascinating things up there is that if the energy really is transferred and the super high electricity is generated in the high upper atmosphere, then what essentially happens is the electricity itself, and just correct me if I'm wrong, Lucy, with this, causes, of course, electrons to be either stripped or excited to higher energy levels, mostly from oxygen, and then as they tumble down, they emit light at that 5577 angstrom wavelength, and there's that beautiful green of the aurora. And you'll notice that I'm saying angstroms, and I'm betraying my age here. People who are listening will know that nanometers are now essentially used, but when I studied this stuff in school, back when I was a kid, sonny boy, we only used angstroms, so I still think in angstroms.
I think in angstroms as well.
Do you really? Oh.
Yeah.
Hey, hooray.
So is it the case then that this excitation, it's sort of glowing like a neon sign? Is that how it works?
Yeah, very much so.
Yeah, that's how I think of it as well. And there's a switch that gets flicked on somewhere thousands of kilometers above our heads,
wow.
and makes them glow. And actually, there's a mission called Cluster, which is it's a European Space Agency mission. I mean, there are NASA missions as well that are up there orbiting the Earth right now, trying to understand how that switch gets flicked on to produce the aurora. It's something that humans have been looking at, ever since the dawn of mankind, and still we're trying to find out what's happening up there in our magnetic field.
Now, Lucy, since this is your field of expertise, and no doubt you're paid to go to places like that, it may not apply to you, but for listeners, and maybe even for Duncan, if you really want to see the aurora as the sun is now heating up toward its probable maximum in 2013, get to not just central Alaska, but the best place under the auroral oval, which is like a glowing donut surrounding the magnetic pole of Earth, is Chena Hot Springs, which is this marvelous place about 2 hours east of Fairbanks, right in the smack in the middle of Alaska. And it's so dark there that they're right under the auroral oval, and about half of all nights they get amazing displays of the northern lights. If you want to get there cheaply, I'm going to again give a plug. I feel shameless about this because I don't make any money from it. Bob Berman, that's me, BobBermanTours.com. Go online and it'll show you. We're going back to that Chena Hot Spring next March for the aurora. But you really don't need me. You really get to that part of the world and you'll have the absolute highest probability of seeing those rich greens and sometimes even deep cherry reds, also mostly from oxygen if it's high up, or nitrogen if it's low down from the aurora. I believe that's at a 6400 angstrom, if I remember correctly, about the same wavelength as those red laser pointers.
Ah, okay.
Yeah. You sound like you've seen a lot of aurora.
Yes. We even get them here, as I say, in upstate New York. The ones there, though, are just so alive that they make the mountains of Alaska emerald. They make them green. You look around for 100 miles in all directions, and all the mountains are green. That's how bright the sky becomes. So.
Did they look better when you take a photograph of them? Because I've seen so many images on the internet now, and someone told me that your eye doesn't pick up the color as well as the camera does.
Usually that's true, but if an aurora is really intense, you definitely see the green, that pale green. As I say, it's 5577 angstroms, so it's right smack at the peak sensitivity of the eye. And I'm getting so excited here. I'm hearing like tons of feedback. Okay, that's a lot better. And there's the reds are a lot harder because, of course, the eye is much less sensitive to red light, especially at low light levels. But you'll sometimes get that deep cherry red as well, especially on the fringes. Up there, you're right underneath the auroral oval, as I said, so it often looks as if you're... The best way I could describe it is if you were a drunk that fell asleep on the floor and then awakened under some draperies that were somehow glowing. Let's say you were living next to a nuclear power plant, and all the drapes were glowing in your house, and you're looking up right from below and seeing glowing draperies with the bottom fringes pink or red, and the rest of it green. That's how it looks there, shimmering and slowly undulating and changing their appearance. So you very much do see the colors with the eye. Of course, the film makes it a little more.
That's
A little more,
that's a pretty
obvious
vivid,
stuff.
pretty vivid picture you paint there, Bob. It sounds amazing. I remember I saw it briefly once from my parents' home in the UK, but that was back in 1989, and I think it was a period, Lucy, when the sun was particularly active and had sent off, quite a lot of coronal mass ejections.
Oh, we had March 13th that year in '89. We had
That's
just
when
an
it
amazing
was.
CME,
Yeah.
and we had auroras that went all the way down to Mexico and the Caribbean.
It was very. It wasn't very animated. It was more a sort of homogeneous sort of red glow, but it was still pretty spectacular. It's the only time I've ever seen the aurora, but it was pretty good. Bob, I've got a quick question for you. I'm just looking at the eclipse here, and that just on the on the website here, the SLU website, there's a snap pic button. What does that do?
Oh, that lets members of SLU, you click on that and it's your picture, and it's just on your computer forever. You can also press some other buttons and send it to people, and it's just a great convenience. People can do that when we're looking at that
So can
supernova
you
in the
share?
Whirlpool galaxy or anything.
So you can share pictures that way. Can
Oh
you?
yes. You capture them. So not only can you make the telescope point wherever you like on
Right.
SLU, but then you can take and keep pictures, and even like kind of drop it the way the way Buzz Aldrin would sometimes say, "When I lived on the moon." That's what he'd actually say. He'd say, "When I lived on the moon." And I always thought, come on, it was just a couple of days. You shouldn't say I lived on the moon. Like if I visited London for 2 days, would I say when I lived in London? But he used to say that. So you can take these pictures and you could say, yeah, I took that picture through the SLU telescope
Got it.
last night. And it would be perfectly true. By the way, I want to say that this event, this live lunar eclipse, is sponsored by Transformers Dark of the Moon. That's the new Michael Bay film in cinemas from June 29th. The only way to see it is in 3D. Okay, we're here with our guests, Lucy Green, a wonderful solar astronomer in England, and with Duncan Kopp, another wonderful astronomer who's just done marvelous things. It's an honor to be with these guys. I'm Bob Berman, your host here. I'm on the other side of the world in the United States, and we're watching almost getting towards the end of the total part of the eclipse, but then following that we're going to have the partial phases, which are also very cool. I'm up to talking about anything whatsoever. Anyone?
I'd love to hear from Lucy a little bit more about the sun. I think there was a coronal mass ejection quite recently. I saw some pictures from a satellite. I think it was called the Solar Dynamics Observatory.
Yeah.
And I hadn't seen absolutely mind-boggling images. They seemed fantastic.
Yeah, absolutely. I saw them as well. But they did come from Solar Dynamics Observatory. You're absolutely right. And I remember them getting circulated on the internet really, really rapidly as soon as the event happened. And that's a product of the data of the images being freely available for anyone to have a look at. And there's a fabulous website called HelioViewer, and anyone, you don't have to be a solar scientist, any member of the public can go to the website and look at the images and make your own movie. And that's what people did. But yes, you're right. There was a coronal mass ejection that was so spectacular. I have to confess, I thought it was a fake. I thought people had photoshopped the images. So I had to go back and get the NASA data and have a look myself to convince myself it was real.
Right.
And the reason it was so spectacular was because there was so much material that was thrown up into the sun's atmosphere. So these coronal mass ejections are they're magnetic bubbles, but they also carry the gases of the sun's atmosphere with it. And they get ejected into the solar system. But this time, a lot of material also fell back onto the solar surface, and that's what created these beautiful images. Did you see them with all these dark structures?
Yes,
falling down?
it was incredible, because it seemed to me, of course, that the magnetism is invisible, which is always a bit of a bane for solar astronomers apparently, because you can't actually see those magnetic field lines. But as this material was falling back towards the sun, some of that plasma was getting trapped in the field lines and illuminating them. But then what was really spectacular was when the material hit the surface of the sun again, it was a bit like sort of bombs going off. There was a little isolated brilliant points of light, and that was intriguing. In fact, I'm making a film at the moment for Nova and National Geographic, which is focusing on the sun. So I've spent with my editor quite a lot of time looking at these fantastic solar images now, and they're so engaging. And we sit there and sort of forget our job and marvel at these wonderful images. You always see something every time you look at them. There's something new to see. It seems such an alien landscape, but in such high resolution now. It's wonderful.
That's right. I mean, I found myself this afternoon. I was using this Helio Viewer software, and I found myself just sat looking at the movies over and over. Of actually a different event. I was looking at what the sun has been up to today, and I just caught this another eruption, another coronal mass ejection occurring, and I suddenly sort of caught myself just being mesmerised by these images, and I quite often do that, and I love the fact that the sun is so scientifically interesting, but also so aesthetically appealing as well. And we look at the sun with so many different parts of the spectrum now. So we use visible light, we use ultraviolet light, we use X-rays, and it looks different in each of these wavelength ranges. And then you can put them all together, you can combine the images, and yeah, they're absolutely spectacular. And as I said before, anyone can get hold of these movies as well, which is fantastic.
Isn't this great that we've got scientists here? We have professional astronomers, PhDs in astronomy that just love what they're doing, and they love the things they're seeing. This is not just dry and mathematical and physics equations. These are people who are in love with the things that they study. You're both very fortunate, I think.
Well, I think that's really. I mean, I have to put my hands up here. I can't profess to be an astronomer. I mean, that was quite some time ago now, 15 years ago or so. But it's what led me into my profession, which is now filmmaking, because there are so many amazing stories in science, and in particular astronomy, and the kind of images that we're able to see now are just totally. Well, they certainly excite me, and it's that wonderful process of detective work, for the first time, be it Hubble, or be it the Solar Dynamics Observatory, or another particular satellite. I really get this feel it's a golden age. We're seeing these wonderful images, and it's lovely to be able to sort of weave stories around them of scientific discovery.
I think you're being too modest, Duncan. I know it's said that a person is an astronomer, professional astronomer, if half or more of their living comes from astronomy. There was Milton Humason. You might know his story. He was a mule driver at the old Mount Wilson Observatory, and he became a world-renowned astronomer without ever having any degrees. But if you make more than half your living from it, but in your case, Duncan, I would say that even if you were a waiter, you have a PhD in astronomy. You're an astronomer. There it is.
Well, it's kind of you to say so. It's always been a passion, that's for sure.
Meantime, we're watching the live lunar eclipse coverage presented by slew.com, and we're heading now towards the final, probably 7 minutes before the partial phases begin again. We have seen a normal eclipse. Normal is good in space because, the Mayans said the world's going to end. We want to make sure that they're wrong, and so far they are wrong. We have two distinguished astronomers, Lucy Green and Duncan Kopp, joining us here. I'm Bob Berman. for the live coverage of the